Hey guys, Miss Michelson here. Today I'm filming a video going over the topic for review in geometry, all about triangles. And our first part is asking us to classify the triangles, which really means we're going to name them. So a lot of us want to jump down and try to answer these with like these congruence theorems, but really we're just describing these by their features. And remember, triangles can be named by their angles, and triangles can be named by their sides. So if we take a look at triangle number one, we want to look at the angles in the triangle. And I see that I've got a little right angle box here. This is a right triangle. If I do the angles in my second triangle, I have a 32, I have a 40, and I have a 108. Because I have an obtuse angle, we're going to name this obtuse. And then last but not least, if we take a look at our angles here, we've got a 52, 52, 76. Each of those angles are acute. So we've got a right, an obtuse, and an acute. We've named them by their angles, but now we've got to name them by their side lengths as well. So if I take a look at number one, I've got a side marked here and a side marked here. That tells me that I have two congruent sides. And the name for a triangle that has two congruent sides is isosceles. Triangle number three here, if we take a look at our markings, we have a 1, we have a 2, and we have a 3. So each of those side lengths represent a different value, which is why I gave them a different color, which means that this must be a scalene triangle. All three sides are different. And then last but not least, if we take a look, we don't have any markings on the side lengths of our triangles here, but we do have numbers. I know this one's 9 and I know this one's 9, which means this side is congruent or the same as this side. We might also see it with these little congruent marks through them. And if we have two congruent sides, we have an isosceles triangle. The next thing we learned about in section 4.1 was our congruence statements. And I've color-coded my picture here because this statement over here holds a lot of information. We know that each of these letters represent an angle in our triangle, so we have a J and a K and an L. And then we can put the two letters together to form the three different side lengths. So what I'm told here is that this triangle is congruent to this one, so each of those individual parts are congruent as well. If J is the first angle in my triangle, it corresponds or matches up with angle R in the second triangle. K is the middle letter, it matches up with angle S, and L is the last letter, it matches up with T. And see, I've color-coded them blue, pink, yellow. Now, these were these were the angles. The question number 5 is asking us about those side lengths. So now we've put together two colors. I've got a blue and a pink. Blue and a pink matches up with the first two letters here, RS. K and an L is a pink and then a gold. So that matches up with ST. And then last but not least, L and J. This one's a little funky because it goes from last to first, from L to J is going to go from T to R, from last to first. So we can do angles, we can do the sides, and then the last one here is just writing a new congruent statement. We're just switching up the order. K goes first, so S is going to go first. A is in the middle, so R is going to go next. L is last, so then we have T, R, S, T. I said that all backwards. SRT. All right, and now we're jumping down to everybody's favorite part, is proving our triangle is congruent. Remember, we have 5 different ways we can prove two triangles are congruent to each other. Side, 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 angle, side, angle, 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 side, and hypotenuse leg. So the first thing that I'm going to take a look at is my triangle right here, and I noticed something special. My two triangles are connected. They are intertwined, which means I have to label one piece of information myself. I noticed that they both share, the left triangle and the right side triangle, both share this line MY. So I'm going to put a marking on them. And now that I've added my one piece of information, I'm going to take a look at what my other problems or what else is marked here. I've got an angle and an angle, and I've got an angle and an angle. So the first thing that I'm asking myself here, because I have a right triangle, I want to know whether or not this is hypotenuse leg. So I'm going to draw my little arrow and I'm going to label my hypotenuse. And my question is, are the hypotenuses marked? Is that something that I have highlighted in my picture? And my answer is no. The hypotenuse isn't marked. So it can't be hypotenuse-like. So don't let that right angle box trick you. And if we take a look at our two triangles here, we have two angles marked in each of our triangles and we have a side. So the two potential options here are AAS or ASA. And the only difference between the two is the location of this side. So we got to ask ourselves, is the side in between the two A's? Is it between the blue, not the blue, between the pink and the gold? Or is it on the outside? So if I look between my pink and my gold, I'm not marked there. So it's not ASA. So by process of elimination, it has to be AAS. So I'm going to say, yes, they're congruent by angle, side, angle. And I'm going to write my congruent statement myself. And this time I have to write both of them. So I know that I'm going to say one triangle is congruent to the next, and I just had to match up their letters. So here I'm going to go from pink to gold to this angle here isn't marked, TMY. And I'm going to do the same thing here, BMY, from pink to gold to the non-marked, BMY. And we can do the same thing for number 10. Same thing. We see that we've got two triangles. They're connected to each other. They share a common side. I'm going to mark it, and I'm going to put a little tick mark in it as well. So now that I've identified the piece of information I needed to write in, now I'm going to highlight the other two things that I know. I've got a side and a side, a side and a side. And then angle here is marked, K is marked. I'll kind of highlight that in big. So taking a look at my information that I have two sides and an angle. The only one up here that has two sides and an angle is SAS. And the A is sandwiched right in between the pink and the blue lines. So we can write our congruent statement here. I'm going to say LKM is congruent to triangle. L matches up with H, so I'm going to start with H, and then I'm going to go to K to M, HKM. All right, we're going to flip over. We've got two more of these, and they are overlapping or reflexive triangles. Here, I have two triangles, and I notice that they share a side. So I'm going to highlight, and I'm going to mark that. I'm going to mark the other two pieces of information that they give me from C to S, and T to S is going to be in pink. And then we've got our right angle boxes. So, red flag in my mind, I've got two right angle boxes, meaning that this is a right triangle. So my first question is this hypotenuse leg. So we take a look, and if we think about our hypotenuse, it's directly across from our right angle box. Hypotenuse here. Are my two hypotenuses marked this time? Well, yep, they're both pink. So the hypotenuse is good. And we got to ask ourselves, is a leg marked in our triangle? So this blue line is a leg. So we've got hypotenuse leg, we've got hypotenuse leg. So we can say yes by HM. And I'm going to do my congruence theorem. I'm going to go CAS. I can choose any order for that first one. C matches up with T, so then I'm going to go TAS for the second one. And last but not least, question number 12. I identify here they intersect, my two triangles match up at N. We also have been calling these our bow tie angles. This angle is congruent to this one over here. So I've added the one piece of information that I needed to write in myself. I find my congruent sides, and then I ask myself, can I prove these are congruent? I don't know anything else about my picture. I only know one S and one A. I know SA, and I know AS. But that's not enough for me to prove these are congruent, so I gotta say no. And if we say no, then we can't answer those last two questions. Question number 13 is asking us, what is the third congruence needed to prove the two triangles are congruent by ASA? So we know that I'm going to have two angles marked and a side right in the middle between them. So I'm going to take a look at what I have in my picture. So I've got a side marked in both of them, so the S is good. I've got this angle right here, my right angle box. So that's one of my A's. So right off the bat, from looking at my picture, I know I need an angle, and it has to be next to the blue side. So if I take a look at my two options here, my two options for my angles in the first triangle are N or Q. The only one that's next to the blue side is one right here. Same thing over here. We have R and T. The only one next to the blue side is angle R. So now that we have those angles marked, we can see we have ASA. So what I'm going to write on this box is that angle N is congruent to angle R. And then the last thing we're going to do is our isosceles and our equilateral triangles. It's been a while since we have seen problems like this, but I know that this first one is isosceles because we have two congruent sides. In an isosceles triangle, these two angles down here at the bottom are the same. If this one's 41, this one's 41. So we know y is 41 degrees. Now that only leaves us to find x, and x is up here at the top. We know that if we add all three of these together, we should get 180. And so if I subtract the two values that I know, 180 minus 82, x is going to equal 98 degrees. If you like, I'm going to do this over off to the side. You don't have to write this down, but if you like to add these together first, we've done this a lot in class, and then subtract from 180, that's how we can get the 8 or the 98 as well. And then last but not least, if we take a look at 15, we've got an isosceles triangle again because we have two angles down here that are congruent. Now, the side lengths aren't marked on this triangle, but I know that the ones directly across from those angles are the two that are congruent to each other. So I don't need actually to use this 22. That was just extra information. My two congruent sides, this is congruent to this. So 2w plus 4 equals 24. And now we can solve for our missing value of w. I'm going to subtract 4 from both sides. 2w equals 20. And then the last thing I'm going to do is divide both sides by 2. My 2's cancel each other out. 20 divided by 2 is 10. And that is the last question on our review. I hope this helped y'all out, and hopefully we are ready to take our topic 4 test.